Hi there and welcome to this video for Senior Physics on Electromagnetism and Electricity. In this video we're going to look at capacitor structure using the PhET simulation. So the PhET simulation, you can see the link is up at the top here. I'll also include it on the post in the actual course. So let's load up the course and see what we can find about capacitors. Okay, so when you load up, you go to Capacitor Lab and you'll get this screen which will come up here. I'll just enlarge it for you here. Now what we've basically got is over here we've got a battery, and that battery is then linked to two plates. Those two plates basically are going to be your capacitor. Now what you can see, we've got charges set on these plates. Now if I put it onto 0, completely discharge the plates, we'll see that we've got no charges on each of the plate. Now basically what we can do with this simulation is play with a number of things. We can actually put charge onto the plate by loading up the battery. We can also use these meters on the right hand side here to basically set up and have a look at what's going on inside each of our capacitors. Okay, so firstly I can look at capacitance. Now remember, capacitance is basically how much charge an area can, a capacitor can store. Now remember, we've got separation of the plates and we've also got plate area. Now obviously if I increase the plate area, look how the capacitance goes up. Okay, so I can keep increasing up to about 400 millimeters squared. And you see how the capacitance goes up. Make it smaller, basically I've got less capacitance. I can store less charge. Now remember, one of the analogies I've used is a water barrel. You can have a large water barrel which stores a huge amount of water, or you can have a small water barrel which only stores a small amount of water. Well, capacitance is exactly the same, but in this case we're talking about charge. So basically we can see that by increasing our plate area, we can increase the capacitance, or the amount of charge which is stored. Okay, so what else can we look at? Well, we can also look at our plate charges, and we can look at the charges which are going to be set up. Once we set up our plate, we can look at the amount of energy which is stored between the plates, and we can also add a voltmeter. Now the voltmeter will look at the voltage across each of the plates, or the potential difference across each of the plates. Now if you remember, Q equals capacitance times voltage, we can use this to actually ascertain what's going on and calculate the amount of charge. Okay, so let's have a play and let's see what we can do. Well, firstly, what we'll do is we'll go over to the battery and we'll see what happens when I increase the voltage of the battery. Now, basically, I like to think of the battery as pushing electrons onto the plate. Now, you can see that we can go in two directions. We can go 0 to 1.5 going upwards, or 0 to negative 1.5 going in the opposite direction. So let's go upwards. Now, you can see as I increase the voltage, I can increase the amount of charge which is being put on the plates. Now you'll see that what's happening here, we've got a certain size capacitor, and you can see I've got fully charged, and what I'm doing is now adding more and more charge to the top of my plates, and the result is I'm varying the amount of energy. As I decrease the voltage, I've got less energy. There's less push to put the electrons on each of the plate. I take it in the opposite direction. Same sort of thing, but the charges go in the opposite direction. Now what that's meaning is if you see as it moves, we can see we get a flow of charge moving in varying directions. Now also what I would like you to note is the voltmeter over here. So if I go up to a maximum voltage of 1.5, like so, you can see that my voltmeter here is basically showing 1.5. The PD across the plates, the potential difference across the plates, is exactly the same as the potential difference across the battery. Obviously, if I lower the battery charge, let's go halfway, I've got approximately 0.625 volts there. I can use my voltmeter to check what the charge is there, and look, it's 0.625 there. So that's an important thing to know, that the charge on the potential difference on the battery will be the same as the potential difference on the capacitor. Now that's useful when we look at our next unit, when we look at series and parallel. So we know that we can increase our plate area, which increases our capacitance. But also, let's see what happens if we remove if we change the separation. Now look at the stored energy when I start moving my plates away. You see that the stored energy basically decreases. Now the reason why that is because they're further apart, there's less affinity for the electrons to move from one place to the next. However, if I start pulling them closer, you can see that the charges will vary. The charges actually get close together. I get more charge which is generated, which means I'm storing more energy. So I can increase the amount of charge by increasing the plate area, like so. And I can also increase the amount of energy by either by decreasing the plate distance. Remember that was little d on the little video. So we've got the idea that we can change the area of the capacitor, we can change the distance, and that's inverse. Basically, the closer it is, the bigger the amount of energy and the bigger the capacitance. The other thing that I can add to it is a dielectric. Now if you go to the top here, this now allows us to add a dielectric to our capacitor. Now remember, a dielectric is basically an insulator. Now you notice that at the moment the only insulator we've got here is air. So as they come closer together, what we're finding is there's more affinity for the electrons to want to move to the positive plate. So the dielectric prevents that, and by putting a dielectric or a synthetic insulator in there, I get a better insulation between the two plates. So let's put one in and see what happens. Here I've got just a custom piece of insulator. Now what I'm going to do is load up my meters again so we can see what's going on. I'm going to put my voltmeter in here as well. Just move it to one side. Now we'll just check our voltage that we've got here. Our voltage is reading 0.7 across the plate, across the battery, sorry, and we'll just check what it is across the plate. And we've got 0.7. So again, we've got exactly the same voltage on the battery as we've got across the capacitor. Just also worth remembering that this is pushing electrons onto this plate, taking them from this plate here. Now when this push is equaled by the repulsion of this plate here, there's no net movement. That's why when you see me change the dial, you see the arrows which are generated. The arrows generated until the push from this plate equals the push from this plate. Alright, so let's put our dielectric in and see what happens. Now this is just a custom made dielectric. As soon as I start putting in the dielectric, watch the stored energy. Watch the plate charge. I'm able to get more charge which is held in the plates to the point that the stored energy is really, really big. Notice if I go half the distance, I'm going to actually find that I'm going to get generally half the amount of energy which is stored. Now obviously different types of material are going to have different effects. I could also put my dielectric in and decrease the separation. And look how the stored energy value down here changes as I change the separation. Okay, getting closer, I'm getting more charge which can be packed on, which means that I'm getting more energy which is generated. It also means that my capacitance is also going up. So by changing the separation, I can actually increase the amount of energy. Let's see what happens if we put a different dielectric in. So if you come over to here, you've got an opportunity to choose a variety of dielectrics. So let's put some Teflon in there. So we're going to put Teflon in. Now remember, when we put our custom made dielectric, this went right up to the top. But look what happens when I add my Teflon. Teflon's not as good an insulator, which means that as a result, I don't get as much energy which is stored. Let's change that for paper. Okay, now this has a dielectric constant of 3.5. So you can see that we're getting a lot more energy which is stored compared to our Teflon. So remember, Teflon was 0.43 times 10 to the negative 13 joules at this point. Dielectric constant of 2.1. Paper, dielectric constant of 3.5, jumps to 0.71. Let's try glass, which has a dielectric of 4.7, and you can see it goes up even more. So by changing a different type of dielectric, what that's going to do is increase or decrease the amount of energy that can be stored. Notice that the voltage across the terminal is still the same. Okay, so we've got 0.67 volts at each end. So basically what that now means is that we've got the opportunity to play around with various capacitors. You can change the separation, you can change the plate area, we can add a dielectric, and as a result that allows us to set up different scenarios. We can disconnect our battery if we wanted to, and we can see the amount of charge which are being placed on. We can look at the potential difference across our plate. Now you can see this is now fully charged. We can connect back our battery, so there's a variety of things that we can do. Now when we get up onto this bit area on multiple capacitors, I'll show you what happens when we've got series and parallel and how that all works. Okay, well I hope you found that useful. Do go onto the link and have a play, and I look forward to you meeting me again when we'll use this PhET simulation to look at series and parallel capacitors. Thanks for watching.